So this is my first video explainer about the problem from this week's homework, about the one-dimensional inelastic collision. Alright, so this is the problem. This is really the scenario. The problem is divided into three parts, A, B, and C. But there's block 1 of mass m, E equals 4.9 kilograms, is moving along a frictionless track with speed v1 equals 23 meters per second, and it collides with block 2 of mass m2, which is 47 kilograms and was initially at rest, so 0 meters per second initial velocity, and the blocks stick together, which is how we know it's an inelastic collision. This is important when we're solving these problems. You have to recognize that if two things stick together, it's inelastic, and it's generally elastic if they bounce apart. Yeah. So kind of our approach, strategy, situation, be helpful to draw a picture. We have to keep track of what we know in this case, and since there's three parts, the first part is asking us to find mass, basically use the masses and velocities that we've been given to find the total momentum. And then part B is use conservation of momentum to find the final velocity of the two blocks that are moving together after that collision. And then part C is using the kinetic energy, changing kinetic energy formula, and then of course kinetic energy, to find the energy that the two-block system has before and after the collision. Alright, and so here's a little sketch. On the left we've got the blocks before they collide, and so we can see they're separate masses, and only one has velocity, which is important. And then in the second drawing here we can see that the mass is the total mass, and the velocity, they're both moving with the same velocity. Alright, and so finding total momentum. This part's pretty straightforward because the larger block has no velocity, and because momentum is velocity times the mass, we know that the only momentum that we have to find the total momentum in the system for this problem is simply the momentum of block 1, the 4.9 kilogram block. And so we know that, mass 1 is 4.9 kilograms, we know mass 2 is 47 kilograms, and we know the velocity initial of the first block is 23 meters per second. So all we do, we plug into the momentum equation, which we've been using in all these problems. 4.9 times 23. And what we get is 113 newton seconds. And so that is the total momentum in the system, and also the initial momentum of block 1. For part B, we find the final velocity. This one is basically just conservation of momentum. We know that because it's inelastic and the second block has no momentum initially, when they collide, they're going to have the same total momentum that's in the system, because the momentum isn't just disappearing out of nowhere in this case. There's no friction or anything like that. And so when they collide, they have the same momentum. It's just their velocity and mass has changed. And so then we, as you can see, we sort of re-plug it into the equation, but this time we're solving assuming that there's two masses combined. And so when we do that, we get 2.17 meters per second. This is in the same direction as the initial motion. And so, yeah, we're able to do this because momentum is conserved. And so just remember, when momentum is conserved and it's inelastic, it's usually pretty straightforward to find the final velocity of the two blocks, as long as we're given the initial velocity. And then for part C, find the change in kinetic energy. This one, kind of a weird twist, like very much a departure, but it's very related, of course, because in other problems in this problem set, we had to do a lot of, you can use like potential energy, and when it becomes kinetic energy, and using that difference to find momentum and things like that. But anyways, find kinetic energy initially, and then find the kinetic energy of both blocks together after the collision, so the final kinetic energy, and then subtract final kinetic energy minus initial kinetic energy. And we know that kinetic energy is 1/2 mv squared, or linear kinetic energy. And so when only the small mass is moving, the second mass has no kinetic energy, because that formula involves involves velocity. And so if there's no velocity, everything equals 0, k equals 0. So ki is equal to kinetic energy of 1 initially. So that's just 1/2 m1 vi1 squared. And so when we do that, we get 1,296 joules, and then the final kinetic energy, similar to momentum, we're just adding the masses together and then using that final velocity that we solved for in the last problem, and we do a little math and we get 122 joules. And so now we subtract the initial velocity from the final, and we get negative 1,170 joules being our change in momentum. This is a pretty straightforward problem, I would say. Just remember that the collision is inelastic. That's really, and once you know that, and we know that obviously one block isn't moving, and so the total momentum is in the block for the system is carried by the block that is moving initially. And that's really all you need to solve this problem. Thank you.